Hi, welcome to this session of mathematics, and today we are going to learn about polynomials. Let me start with something even more familiar like polygon. Polygons are the shape with many sides, like we have studied pentagons with 5 sides, we know hexagons with 6 sides, then there are decagons, septagons, so many shapes with many sides, then they are called polygon. Similarly, polynomials are the expression with many terms. Poly means many and nomials mean terms. So, an expression with many terms will be called polynomials. Let's take an example. 3x cubed plus 9x square minus 2x minus 7. But the exact definition of polynomial is the expression which has more than 3 terms. We can see there are 4 terms in this, that's why these are called polynomial. What about the expression which has less than 3 terms? So let's say if we only had 3x cubed with us, then it would be called a monomial. Similarly, if we had along with 3x cubed 9x square, it will be called binomial. Again, if we have 3 terms, then it will be called trinomial. Now this makes me to think, what exactly is the function of polynomial? Where do we use it in real life? Well friends, we will later see that if we represent polynomials on graph, then they form curves. And in real life, where can we really see curves? We can see curves in the roller coaster rides, right? So something as gigantic as roller coaster rides actually take help of something as simple as polynomials. Amazing, isn't it? We will learn about it in our later sessions. But first, let us see what are the real components of a polynomial. Let us again take the same example. So these letters that we see over here, like x, these are called variables. And why do we call them variables is because we don't know their value. So instead of x, there could have been y, z, or anything that you would want to label it as. Then these numbers that we see right in front of these variables are nothing but the coefficients. We also call them constants because they have a particular value. In this case it is plus 3, then plus 2, we have minus 9, then we have minus 7. Again, what is the third thing that we can see? We can see that there are some numbers even on the superscript of these variables, like 3, 2, then over here we have 1, then actually we have over here x raised to the power 0, which is nothing but equal to 1, so we prefer not to write it. So these numbers on top of the variables are actually called the powers or the exponents. Now this polynomial, which is only in terms of x, will be called as px, and this px has a highest power of 3. So this highest power of 3 is called the degree of this polynomial. We can see these powers are decreasing, right? 3, 2, 1 and 0. So this acts like the maximum limit of the power that a polynomial can take at a point of time. Similarly, if there was a term with the power 4, then the degree would have been 4. Now this was in case of polynomial with only one variable x. What about polynomials which have more than one variable? Step 1 would be to identify what are the powers of these variables for every term. We can see that there is one power for every term. Over here, then we have x raised to the power 0, y raised to the power 0, or z raised to the power 0, correct? Which if we don't write also doesn't matter. Now the next step will be to add these powers. Over here we have 1 already, and then we have 0. Now we will check where is the sum highest. And we can see over here we have the highest sum. So this will be called degree of this polynomial with multiple variables. Now why are we focusing on this degree so much? Because on the basis of this degree, actually we can classify polynomials into various types. Let's see how. So a polynomial which has a degree of 3 will be called a cubic polynomial. Now if we did not have this particular term and it was only till this point and the highest degree was going to be 2, then this would be called a quadratic polynomial. So a quadratic polynomial is a polynomial with degree 2. Let's say we did not have even this and there was only this portion of it and we had 9x minus 7 as our polynomial, then the highest power would be 1. Then this would be called a linear polynomial. And why we actually call this one as linear? Because if we plot it in a graph, then we would actually get a straight line. So that is why linear. Okay, so let us make a table so that we remember it properly. So first column would be degree, then we have types of polynomials, then we'll write an example so that we understand it better. Okay, so when the degree is 1, the polynomial is of the type linear polynomial. For example, let's say 3x plus 7, we have only 1 degree, right? When the degree is 2, then we have quadratic polynomial. Let's say for example 3x square plus 2x plus 7. Then when we have a degree of 3, then we call it a cubic polynomial. For example, let's say 3x cube plus 2x square plus 7x plus 9. But what can we notice over here? We see that as the degrees increase, even the terms increase. But why? Because these degrees are nothing but the highest powers, and below these highest powers are other terms which contain lower power than this. So 3 will have 2, 1 and 0 below it. Similarly 2 will have 1 and 0 below it, and 1 will have 0. And that is the reason why the terms also increase as the degrees increase. So now we understand what exactly is a polynomial and what are the components of it. But is there a way to identify polynomial? Can there be something which will not make a polynomial? Yes, there are certain things which doesn't make a polynomial. Something like negative power. What do I mean by that? Let's consider a term 3xy z raised to the power minus 8. Over here we have a negative power which is not allowed when we want to make a polynomial. Similarly, till now we saw that variables are always multiplied with the coefficients. Let's say if we divide the coefficients by the variable, then also we will not be able to make a polynomial. So division with variables is also something that is not allowed. Let's say we have root of x. Now we can write this as x raised to the power 1 by 2. So we see that the power for the first time is in fractions. It is rational. So rational power is not allowed. So these are the features in a term that does not make a polynomial. So as soon as we see these features in a term, we will know that it will not make a polynomial. Now let us go back and look at what all we studied today.